Today is Wednesday, the 6th of November, 2019. Year of our Lord 2019. We're in free algebra, and we're learning to find least common multiples. Why? Because it's going to help us to identify the least common denominator when if we have to add or subtract fractions. And they may or may not involve variables. So we're taking you back to find least common multiples, not the old-fashioned way where you would write the multiples in a list, find the common ones, find the least common, and say that's going to be my LCD. We taught you a new way, same with factors, and that is prime factorization. So we take all of the numbers and boil them down to their primes, either by a tree, that inverted division sign, and we find all the primes. To find the GCF, I'm saying this on purpose to try to get you to say, wait, I still get confused by those. Why are you doing that? Because then you work through the cognitive dissonance. Ooh, there's a big phrase. Those things that confuse you, and you got to keep working through them so they don't confuse you anymore. We found the greatest common factor by finding the common prime factors, right? And using as many common ones as there were for each number. That's not how we find the greatest or the least common multiple. Least common multiple, we don't even care if they're common. We multiply each factor and we use the one that's the highest power. Make sense? Yep. You sure? Well, hopefully you will as we go. All right. So there's your answers to yesterday's work. Obviously, if you weren't here, you're going to have to get those answers down, though. I am okay with you writing the answers and then doing the problem and checking to see. Because it does you no good, Kiara. And anybody else that misses, I can imagine a student, not mentioning any names, that thinks it's okay. Like if they missed and I had the answers on the board, and they're like, oh, I got all the answers. I got them all right. Like, what does that do for you? Nothing. Yeah. Because your grade is just dependent on doing it for homework, but then the bulk of your grade is knowing how to do it. So what's it matter if you like, oh, I got all the answers right and I didn't have to do them? That is like, that makes no sense at all. Yeah. Yes? You don't understand 9? Okay, 9. Your two numbers are 6 and 21. So, you mind if I do it this way? I'd like to change it up so that you realize it doesn't always have to be a tree. Okay. When you're finding least common multiple, Kira, it doesn't even matter if they're in common. You use every prime factor and you multiply them together, and if there's a 3 in this and a 3 in this, but let's say over here there was a 3 squared. Well, then you would have used a 3 squared. But you use every prime factor and multiply them together. Yes?
Could you make number 12 for me? I got 18.
Okay, 36 and 90. First of all, the only way you could possibly have gotten 18, Kara, is if you did the classic, ready for this? Some people were doing it yesterday. You did the classic factor instead of multiple. Let's go back to the difference between factors and multiples. You know what the greatest common factor for 36 and 90 is? 18. So you found the greatest common factor. It's classic. Listen, if you've already done this and you do it again today, it's not the worst thing in the world, but again, we got to keep addressing it so you don't keep doing it. Factors make products. So you need small parts to make the big part. You go to a factory. They're in there. They got an assembly line going. Everybody's got one little part. They put all those parts together. They get the final product. I thought that would be, I always use that because I think it's easy to understand. So factors are always smaller than the number, okay? Or it's the number itself. Multiples, think about your words. Multiples are, I'm multiplying that number. It's getting bigger, right? So if you're still confused between factors and multiples, join the let's see, I would say after doing this for about 3 days, join the 47% of middle schoolers that still kind of confuse those two. So almost half of middle schoolers still sometimes have to stop and think, or at least do that, if not still be confused between the two. So Kiara, that's what you did. You found the greatest common factor, which is 18. So when you do your prime factors, Kiara, you tried to find the ones that were in common and multiply those together. When you do multiples, you don't care if they're in common. You use every prime factor to its highest power. Okay, we got to keep going. The train, listen, Mr. Franken's okay if sometimes the train slows down really slow and even comes to a stop, and we're there in the depot for like a day. But eventually the train's got to keep going down the track, right? Or we'll never get to where we're trying to get. Or at least I'm trying to get you to. I misspoke. I said we'll never get where we're trying to get. Where you're trying to get is like out of class. We'll never get where I'm trying to get you to get. Because if it was left to you, you wouldn't be getting anywhere. You'd be like, you'd be home in bed.
I probably would.
Okay, here we go. Miss Stroken is not, she's not afraid, she's not intimidated by the letters. Because what she's going to do is she's going to take this number 20. Oh yes, keep going here. This is your homework, but I'm doing it with you. Number 20, we're adding on to number 19. She's going to take number 20, and she's going to look just at the constants, the 5 and the 7. And she's going to figure out the least common multiple for 5 and 7. What? 5 and 7 are both 5. So she's going to multiply 5 times 7, and that's going to be that part of the least common multiple. You with me? I haven't thought about the letters yet. I'm working just with the constants, the 5 and the 7. What's the least common multiple between 5 and 7? 5, 15, 20, 25, 30, 35. 7, 14, 21, 28, 35. First one you come to is 35. Or you could have used the prime factorization method and said, they're both prime, we'll just multiply them together. Got that? So the first part of this is 35. Raise your hand if you don't understand that. That 35 is the least common multiple between 5 and 7. Okay, now watch. This next part is not, oh, you raising your hand?
Yeah.
You don't understand that's the least common multiple? Okay. I'm just going to attack the numbers, the constants. And I'm going to find the least common multiple for 5 and 7. If I had to add those two fractions, could I add them as it is?
No.
Can't add a fifth and a seventh. They're not the same thing. If you don't understand that, guy goes into I can't add fifths and sevenths. Some of you are out there like, that has to do with the pizza shop?
Yes, it does. Very much so.
Very much so.
I think we could.
You can't add fifths and sevenths, David. So you would have to find a common denominator. You would have to find the least common multiple, and that would give you your least common denominator. And you would go through the process in 5th grade. Remember those charts? You had to list them. 5, 10, you had to list 6. Okay? So if you need to do that. But you would do that, and you would find out the first one you come to in both lists is 35. So you would change them both to the 35th. Does that make sense? But now you don't have to make those charts. 2 prime factors, multiply them together. 35. Okay. Look, the letters part is actually even easier. What's the rule for finding least common multiple? It's to take every factor and use the one that's the highest. You guys aren't even engaged at all. This is like, it's like you're showing up every day this week like, what's he saying? The rule for least common multiple is to take every factor and use it to its highest power. I have an A here and an A here. Which one's the higher power of A? They're both the same. So it's just A. I have a B here and a B here. Which one's the higher power?
B
squared.
to the power
So guess which one I'm going to use?
B squared.
There you go. That's your least common multiple.
Yay!
Give her a hand. Look, what did I do? Rachel, I took my numbers first. Who remembers yesterday I had you read the rule like how many times?
9.
7 times.
7
Yeah.
times.
The number of completion.
I get it.
But when you read the rule 7 times and you had no faith that you were going to, you weren't like Naaman washing in the Jordan. He had faith when he washed 7 times to get rid of leprosy. But you read it 7 times, just kind of like, okay, he said to read it. I don't even know what I'm saying, but I'll just read it.
I get it.
It should be stuck in there. Listen, how do you do it? You use all the prime factors and you use them to the highest power. I have a b and a b squared. Which one am I going to use?
B squared.
B squared. Done. Number 21. Are you already done with 21? Who out there is already like, Mr. Rankin, I'm already, you, like the caboose. I'm way ahead of you, bud. Okay, 21, let's do it. I'm sorry, yeah, 21. 7s cubed 49st squared.
Whoa.
Where'd my black marker go? I'm trying to be so
That way.
neat and organized on the board today. It's just not my thing. I'm usually all over the place.
I have the answer.
So it actually is harder to stay neat and organized. 21. You got the answer? Let's see if yours matches mine. 7s squared or cubed t.
49.
I think that's the answer.
49s.
3, 2, 13.
Are you trying to confuse me on purpose?
Okay.
Okay. What do I do here? I just look at the numbers. What's my least common multiple? Hey, back in 5th grade I gave you this clue. If you have a 7 and a 49, and those, remember, I need you to start thinking of the whole business. Multiple is to find the least common denominator. So if your denominators were 7 and 49, remember this trick? If the little one goes into the big one, the big one's your least common. So I didn't have to do much figuring on this. 49 is my least common multiple. I didn't have to do the factor tree. If the little one goes into the big one, boom, done. 49 is your least common multiple. Now look, use the rule. The letters are easier. You have to use all the factors, so I have to use an S. Which S am I going to use?
S3.
S cubed. We don't say S3, we say S cubed.
Where the cube is.
There's T's. I got to use the factor T. Which T am I going to use? T squared. Because it's the higher power. You have to use all the factors to the highest power. Are you done with 22?
No.
If you did 21 ahead of me, did you get it right?
Yeah.
No. Yes.
Number 22. 4x cubed y cubed.
How?
Actually, give it to Micah.
Look at just the numbers first, 4 and 18. If I did the prime factorization of 4 and 18, and by the way, I always encourage mental math. If you can figure that out mentally, by all means do it. But if you get it wrong, you got to show our work. I love when I say that. Do we have to show our work? Yeah, if you get it wrong. That might not make sense, but it totally does. Because if you're able to figure that out mentally, that it's 36 without doing the factor tree, without doing the list of multiples, God bless you, that's good. But you have to know how to do the prime factorization, especially if you're trying to do it mentally and all you're doing is guessing. So if you knew it was 36, let's prove it's 36. I got to use both factors. I got to use the 2 and I got to use the 3. Over here it's 2 squared. It's only 2 over there. It's 3 squared. What's 4 times 9? That's how we arrived at 36 being the least common multiple of 4 and 18. Noah might have been thinking to himself, well, let's see, 4 doesn't go into 18, so it can't be that. Oh, by the way, if you're using that strategy, does the little one go into the big one? You know what the next step in that strategy is?
Multiply by 2.
If 4 doesn't go into 18, do the next multiple of 18 and see if 4 goes into that. What's the next multiple of 18? What's 18 times 2? Does 4 go into 36? Boom, done. You get it, Ev? So I got 36 for the numbers. I've got an X there. I have to use every factor. So I got to use an X. Which X am I going to use? I'm going to use the higher power. I'm going to use which Y?
Y.
Y to the 5th. Higher power. That's it. Sometimes we're confused because what do we keep saying? I'm confused. Listen. Do you understand the arithmetic part? The 4 and the 18. Okay? If I had a denominator of 4 and a denominator of 18, 36 would be my least common denominator. Do you get that part? Okay, so Kara,
But the 2, when you were doing the prime factorization, why couldn't you just take out the 2?
why can I take that out? Because over here it's 2 to the 2nd power. Over here it's just 2. I got to use 2, but I got to use the 1, just like the letters here. Look, why am I using the x cubed and not the x? Because it's the simple rule is use the 1 to the higher power. Why am I using the y to the 5th instead of the y cubed? Because the rule says you got to use the 1 to the higher power. Number 23. Whoa, that's big. 20c squared b cubed.
I think I got it right.
60c. Is that d to the 6th? Okay. Before I do the numbers, Kiara, are you realizing how easy it is to knock out the letters, the variables? I have a c squared and a c squared. What am I going to use? C squared, because that's the highest power. I have a d cubed and a d to the 6th. Which one am I going to use? Okay, so you got that down. You got it. That's it. Some of you are like, wait, can it be that simple? Yes. So now I got to work with 24 and 60. 24, I don't know my multiplication times tables all the way to 24. And even though I'm pretty good mentally, maybe I don't know that 24 goes into 60 or 24 goes into 120. I mean, I do, but let's pretend I don't. So I'm going to go over here and do the prime factorization of 24 and 60 and prove to myself that it's going to be 120. Let's prove it. 24, 60. I'll do a tree this time. Okay. For 24, I've got 1, 2, 3, 2 cubed times 3. You with me? For 60, I got 2 squared times 3 times 5. You with me?
Mm-hmm.
I have a 2 as a factor and a 2 as a factor. Which one am I going to use?
2 to the power of 3.
2 to the higher power. I'm sorry, what is 2 cubed?
2 to the 3rd power. 8.
I've got a 3 here and a 3 there. What am I going to use? 3.
24.
I've got a 5 here, but no 5 there. What am I going to use?
5.
5. I've got to use all the factors. 8 times 3 times 5. What is 8 times 3 times 5?
120.
120. So the answer is 120 c squared d to the 6th.
Yep.
Yes.
Yes.
This is awesome. You guys are doing much better today. All right. No.
Ron doesn't do his homework.
Yeah.
All right, listen. My plan was that you were actually going to do the review quiz and have it done before. Time's up. On page 191. I think you could do it, but I can't make you do it because there's only 14 minutes left. So, no, 1 through 13, you're working on it now, but it's homework. And listen, this is the difference. You can't talk because this time I'm not just taking it as a 5-point homework grade. I'm actually grading it as a quiz.
What?
Page 191. You're turning it in. Instead of 5 points, it's 26. Shh, you can't be talking. And you get to take it home because I ran out of time. Just Kara kept saying,
Yeah.
So,
listen, if you're talking, that's 26 becomes 0. Yeah?
can I put it on the bottom of my homework?
No, it needs to be on a totally clean sheet of paper. You're turning it in. Page 191, review quiz 1. No, don't give me graph paper. If you turn it in on a half sheet or a messed up sheet, I'll be, when I hear Mr. Lamb does, I'll just throw it away. You gotta do it again.
I only have.
Turn it in professionally. If you need paper, ask.
We're doing one.
You either have a loving neighbor or me, give you a sheet of paper.
I need paper.
Listen, you're not listening. 191, 1 through 13. You're kind of on your honor, not looking in the back of the book. You're on your honor, doing it for homework, not getting answers from friends. Listen, it's a 26-point grade. If you think it's worth lying, cheating, breaking the commandments for those 26 points, that's between you and your God. I mean, I'm not going to make you get it done in the next 12 minutes, so I'm giving you to have it done for homework. What you do with that is, it's up to you and your integrity. Yes?
Can we look back?
You can look back in the book, yes, to help you with examples, to help you do it, but you can't look in the back of the book.
I see what you did there.
Oh, that's the little, see what I would do a lot is, I would give the answers to the back to that review test. And again, you understand my point to doing that? Like, you do the problem and then you're affirmed by the answers I give you. So you actually keep that for later. Because Ethan, do you realize how some kids will go, oh, I got all the answers, yay. How does that benefit you? If you're studying for a test.
Do you have to do the work on the same sheet of paper, or do you want to do it?
Dominic, for 1 bonus point. Who lived to be that age? Dominic.
His name's.
Shh.
I know.
Whenever I see that number, I think of this person. Even though I didn't know him, of course.
I know.
Raise your hand, don't say it. Dominic, go ahead.
Oldest person alive.
What's his name?
I know. It's.
Oh, he's got the first letter. David. Methuselah. Can you spell it? Shh.
No, what's that?
Shh. Nope.
What?
IT. IT.
Come on.
I thought it was Mr. Henry.
I said, could you spell it?
Yes, I can spell T.
I said, can you spell it? IT. I see what you did there.
I see what you did there.
Okay, quiet. I know I'm guilty of breaking the silence, but back to
Yes.
Come on.
That's not the first letter.
Here. No, listen, it can't be a, oh, that's factor, I'm sorry. So it can't be a factor of 24 if it's bigger. That's all I can do. You can't have a factor of 24, be larger. So the rule for factors is that find just the common ones and multiply them together. For multiples, it's all of them to the highest power.
Oh, wait,